Hi everyone, this is Bhumika Sharma, student of Sikkim Government College Namji, pursuing BSc in Physics. Today, I am going to talk about the IR and ICPOES, that is, infrared spectroscopy and inductively coupled plasma optical emission spectroscopy. Before starting my presentation, first of all, I would like to thank our teacher who gave us this assignment to do as a seasonal 2, that is Dr. C.P. Khatiora sir and entire physics department of Namchi Government College for giving me such an opportunity to do assignment or can say presentation on such a wonderful topic. So, moving forward with the presentation, here is the topics I'm going to talk about in this video, that is infrared spectroscopy and inductively coupled plasma optical emission spectroscopy, ICPOES. Here is the introduction of infrared spectroscopy, IR. Infrared spectroscopy, that is IR spectroscopy or vibrational spectroscopy, is the measurement of the interaction of infrared radiation with matter by absorption, emission or reflection. It is used to study and identify chemical substances or functional groups in solid, liquid or gaseous forms. It can be used to characterize new materials or identify and verify known and unknown samples. The method or technique of infrared spectroscopy is conducted with an instrument called an infrared spectrometer or spectrophotometer, which produces an infrared spectrum. So that was all about the introduction of infrared spectroscopy. Let's see the diagram of infrared spectroscopy, that is IR. First of all, it has a source, sample and reference, splitter, detector, processor and printout finally. So this is the diagram of infrared spectroscopy. Moving forward with the principle of IR, infrared spectroscopy is the analysis of infrared light interacting with a molecule. The portion of the infrared region most useful for analysis of organic compounds have a wavelength range from 2500 to 16,000 nanometer with a corresponding frequency range from 1.9 into 10 to the power 13 to 1.2 into 10 to the power 14 Hz. It is known that in addition to the fragile rotation of groups about single bonds, molecules experience a wide variety of vibrational motions characteristics of their component atoms. Consequently, virtually all organic compounds will absorb infrared radiation that corresponding in energy to these vibrations. So that was all about the principle. Here is the instrumentation of IR spectroscopy, that is how it is designed. So let's talk about this. The main parts of the IR spectrometer are as follows, that is radiation source, that we can see in the diagram here. Radiation source, sample cells and sampling of substances, monochromators, detectors and recorders. So this is the instrumentation of IR spectroscopy. Now let's talk about the uses and applications of IR. Infrared spectroscopy is a simple and reliable technique widely used in both organic and inorganic chemistry, in research and industry. In catalysis research, it is a very useful tool to characterize the catalyst as well as to detect intermediates and products during the catalytic reaction. It is also used in forensic analysis in both criminal and civil cases, for example, in identifying polymer degradation. It can be used in determining the blood alcohol content of a suspected drunk driver also. IR spectroscopy has been successfully used in analysis and identification of pigments in painting and other art objects such as illuminated manuscripts. So this is all about the uses and applications of IR spectroscopy. Since it has many applications, but I have mentioned only 3 in this video, although you can refer other things to know the uses and applications of IR spectroscopy. Now, talking about the practical IR spectroscopy, the infrared spectrum of a sample is recorded by passing a beam of infrared light through the sample. When the frequency of the IR is the same as the vibrational frequency of a bone or collection of bones, absorption occurs. Examination of the transmitted light reveals how much energy was absorbed at each frequency or wavelength. This measurement can be achieved by scanning the wavelength range using a monochromator. Alternatively, the entire wavelength range is measured using a Fourier transform instrument, and then a transmittance or absorbance spectrum is generated using a dedicated procedure. That was all about the infrared spectroscopy. Now, let's see how important it is and what are the future scope of this thing. Okay, so future scope of IR spectroscopy. Over the medium to long term future, the analyst anticipates the IR spectroscopy market to regain growth momentum, mainly with support from developing market. Scope of the IR spectroscopy market report includes the base year for the market analysis is 2019 and forecasts are provided from 2020 to 2026. So that was all about the IR spectroscopy. Now moving forward with the inductively coupled plasma optical emission spectroscopy. It is inductively coupled plasma atomic emission spectroscopy, ICPOES, also referred to as an inductively coupled plasma optical emission spectroscopy, ICPOES, is an analytical technique used for the detection of chemical elements. It is a type of emission spectroscopy that uses the inductively coupled plasma to produce excited atoms and ions that emit electromagnetic radiation at wavelengths characteristics of a particular element. The plasma is a high temperature source of ionized source gas. Often it consists of argon. The plasma is sustained and maintained by inductive coupling from cooled electrical coils at megahertz frequencies. So we talked briefly about only the introduction, actually, about the inductively coupled plasma optical emission spectroscopy. Let's see its diagram. So here is the diagram of ICPOES. It consists of first radio frequency generator. Here is the argon gas cylinder, nebulizer, sample, pump, transfer optics. Since it is a optical emission spectroscopy, so it consists of optics also, and spectrometer over there, microprocessor and electronics, etc. Now talking about the principle of ICPOES, ICP, abbreviation for inductively coupled plasma, is one method of optical emission spectrometry when plasma energy is given to an analysis sample from outside. The component elements, that is atoms, are excited. When the excited atoms are returned to low energy position, emission rays, that is spectrum rays, are released, and the emission rays that based on the position of the proton rays and the content of each element is determined based on the rays intensity. So that was the first principle. Now let's look to the second one. To generate plasma, first argon gas is supplied to torch coil and high frequency electric current is applied to the work coil at the tip of the torch tube. Using the electromagnetic field created in the torch tube by the high frequency current, argon gas is ionized and plasma is generated. So that was the principle of ICPOES. Let's look upon its mechanism. The ICPOES is composed of two parts as shown in the diagram: the ICP and the optical spectrometer. The ICP torch consists of three concentric quartz glass tubes. On the output or work coil of the radio frequency RF generator surrounds parts of the quartz torch. Argon gas is typically used to create the plasma. And secondly, the ICP have two operation modes called capacitive E mode with low plasma density and inductive H mode with plasma density. And E to H heating mode transition occurs with external inputs. The torch is operated in the H mode. So that was the mechanism of ICPOES. Let's look upon its history, how it came. The first published attempt to use plasma emissions as a source for spectroscopic analysis were in 1956 by Eugene Badarov. In 1964, Stanley Greenfield, working at Albright and Wilson, was the first to use ICP for non-experimental analysis. The first commercial machine was produced by Contron in 1975. So that was the history, brief history actually about the ICPOES. Let's talk about the theory, let's talk about little detail of ICPOES, that is inductively coupled plasma optical emission spectroscopy. ICPOES is a multi-element trace analysis technique used to measure the concentration of various elements in a variety of sample matrices. As we already saw, as we already talked about this thing in introduction also, let me elaborate this topic. Also known as inductively coupled plasma atomic spectroscopy, the technique is capable of measuring the majority of the elements in the periodic table and is currently one of the most widely used methods for element analysis today. The basis of the ICPOES techniques are simple. ICPOES uses an extremely high temperature argon plasma to excite atoms such that they emit their characteristic wavelength of light, that is emission lines. The intensity of the emitted light is directly proportional to the concentration of the elements in the sample. By measuring the emitted light by known and varying concentrations of an element by what's known as a calibration, the concentration of an unknown sample can be determined by comparison. So here in this slide, or can say in this portion, we talked little expanded version of ICPOES, can say. Now talking about the application and uses of ICPOES. ICPOES is widely used in minerals processing to provide the data or on grades of various streams for the concentration of mass balances. The ICPOES is often used for analysis of trace elements in soil also, and it is for that reason it is often used in forensic to ascertain the origin of soil samples found at crime scenes or victims, etc. Taking one sample from a control and determining the metal composition, and taking the sample obtained from the evidence and determine that metal composition allows a comparison to be made. While soil evidence may not stand alone in court, it certainly strengthens other evidences. We talked about the IR, and we talked a little briefly, can say, about the ICPOES. So why is it important and what are the future scopes of ICPOES? Let's talk about this. So ICP, that is optical emission spectrometry, is now highly rated as a multi-purpose analysis technique, and there are over 2000 units of ICPOES used in Japan. It is well regarded as an environmental measurement technique, along with atomic absorption spectrometry and ICP mass spectrometry, and its use is expected to expand even further in the future. So here in this video I talked about the IR and ICPOES little briefly. So here only I'm going to end my presentation. Thank you.